Good day, everyone. Welcome back to this well engineering model. There are three very important components in roller code bit design that we should be looking at and we will be discussing in this topic that we should be paying attention to as drill engineers when selecting drill bits. Those three things are: number one, the journal angle; number two, the offset, that's the bit offset, the bit design offset; and number three, the cone profile. These are the topics that we will be discussing today to ensure that so that after you watch this video, at the end of it, you'll be able to understand the reasons why you're choosing a particular bit based on its offset, based on its journal angle, and based on its cone profile. Good day, everyone. My name is Gokoli, and let's hang on and discuss this model in detail. So, I already spoke about the bit frame component. The first one is the journal angle. Second one is the offset or skew angle, and the third is the cone profile. The first, which is the journal angle, it's what does it influence? It influences the load distribution between the journal and the thrust face. It influences the cutter diameter. It influences the gauge bevel length and also the cutter shell thickness. As the journal angle increases, the thrust position of the load increases. And finally, with 8% difference between 33 and 36-degree journal angle, that's 8% difference in performance. So let me explain everything I've just read out. What this is trying to say is if there is no offset angle, the excavation will be lower. That's the bit being able to excavate through a formation will be lower. So therefore, if the offset angle is higher, sorry, if the journal angle is higher or the journal offset is higher, it's able to dig more. So say you increase the angle, it's able to excavate into the formation. But if you keep it without an angle, it just stabs in directly. I mean, pretty much at the normal. But if you increase the offset angle, it's able to excavate into the formation and dig up the formation. Where would you want to increase the offset angle when designing the bit? If you think about it, you will see where you actually want to do this is for a very soft formation. Because if you increase the offset angle for a bit and it goes into very hard formation, the propensity to break the cutters will really be very high. Do not forget that roller cone bits cut by gouging the formation, gouging and excavating. So you need to apply very high weight on bit for you to be able to penetrate through the formation to gouge through it, then excavate. So if you increase the angle, the general offset angle of that particular bit during the design, and you use that bit to go drill through a hard formation, at that angle, if it penetrates the formation, it will break. So where you would want to increase that journal offset angle is where you expect the formation to be loose, so that it's able to, when you apply high weight on bit, it's able to stab in at that angle and excavate the formation as you like. So the next component we'll be talking about is the offset or skew. Now, just looking at this summary, at reduced offsets, that's zero, there's reduced gauge scraping. At reduced offset, that bit is more durable. If you reduce the offset, it is slower to you. I mean, you will have very slow drilling. And finally, you require to have this reduced offset for hard abrasive formation. So it's this particular component is similar to the journal angle. When or rather, it's pretty much what happens to the journal angle. So when you have an offset or skew from that angle, it will not be nice for very hard and abrasive formation. But when you have an increased offset, the bit is less durable, you have higher penetration, faster drilling, and it's for soft formation. So it's similar, it's pretty much what happens to the journal angle. So that offset is that increase in angle of the journal that helps in excavating the formation. So what is this is saying is that you want to have an increased offset where you have very soft formation and where you know that that formation is soft. And when you have that, you just know that you're able to drill. However, because of that increased offset or skew, that bit is likely not to last long and usually less durable. It also ensures that we have very increased scraping once the offset is increased. Then finally, for the cone profiles, when we have a round nose, we have basically two types: is either round or it's flat. When you have a round nose cone profile, there's increased bottom hole scraping. It's less durable and is meant for faster drilling for soft and sticky formations. And when it's flat, the bit is more durable. The drilling is slow and it's for hard and abrasive formations. So this is what we are saying. Pretty much what we're saying for other two components. When you have a round nose profile, look at this. What we have here, you see that these profiles are kind of round, and with this round profile, you're able to gouge into the formation to create that gouging effect that you need for excavation. But when it's flat, there's this scraping effect, and you need that consistency when you're drilling very hard and abrasive formations. You will need this pointed type of profile when you're drilling through very soft and sticky formation, so you're able to create that that gouging effect to be able to drill through those formations. So that's pretty much it. So for round nose profile, you want to create that excavating effect because of how pointed they are, and with that, it helps to drill faster. But note that that only works for soft and sticky formations. But for flat cone profiles, you will want to use those kind of bits for formations that are very hard and abrasive, because you want to have like pretty much a uniform effect on that very hard and abrasive formation, drilling through that formation and getting that uniform gouging and cutting effect while you're excavating the formation. But note that that drilling operation will be slower because you don't have that gouging effect, that extensive gouging effect that you will be having when you have a round nose profile. So that's about it. Thank you very much, everyone, for listening to this video. And consequent videos, we'll be talking about how we grade these bits post drilling operation, to know that if we've selected our bits properly, to know if the bit that we've chosen for that particular formation and that environment is useful and has been effective. Because once you use a bit for a particular environment, when it comes out of the hole, that will tell, I mean, the grading will tell you if that bit is suitable for that particular environment. Thank you very much, everyone, once again. Please do not forget to like, share, and subscribe. See you in the next video. Bye for now.